Hi everyone, thank you for joining. Today we will be working through a grade 12 problem which requires us to solve for x. We see we've got root 3 multiplied by sine x plus cos x equals to 2. Now we have to attempt to get these trigonometric terms to be similar so that we can make x the subject of the formula. Now the important thing to note is that cos squared x plus sine squared x is equal to 1. Now this is one of the most common relationships we have, and we are going to utilize this. We can make cos x or sine x the subject of the formula. Let's choose sine x in this case, simply because it's first in that expression, right? So we've got sine x equals to 1 minus cos squared x, and we take the root of that. So I've made sine x the subject of the formula. Now let us substitute into the expression or equation root 3 multiplied by the root of 1 minus cos squared x plus cos x is equal to 2. Let us further simplify. On the right side we have 2 minus cos x. On the left side we have 3 multiplied by 1 minus cos squared x, and that will be rooted. Now let us square both sides of the equation. All I am doing is attempting to get x to be the subject of the formula. On the left side we've got 3 minus 3 cos squared x, which is equal to 4 minus 4 cos x plus cos squared x. What I've done here was simply take 2 minus cos x multiplied by 2 minus cos x, right? And we multiply that out. I've done a simpler shortcut method in my head in order to obtain this. Now let us further simplify. In this case I would take everything to the right side. You will see why. I end up with 4 cos squared x minus 4 cos x plus 1 minus 3 cos squared x to the other side becomes plus 3 cos squared x plus cos squared x is 4 cos squared x. The 3 to the other side becomes minus 4 minus 3, that's 1, right? Now let us factorize. We can use the AC method or we can use our calculator. In this case, because the question is so long and I don't think they will give us marks for the AC method, let's just put that into our calculator. We've got 2 cos x minus 1 and 2 cos x minus 1. Therefore cos x is equal to 1 all over 2 and x is equal to inverse cos open brackets and a half. Let's put this into our calculator, and this is 60 degrees. Now here we need to be cautious. Let me show you this trick. Let us draw the Cartesian plane. And let us draw the cos graph. can see I won't have space there. Let me move this. Right, that's perfect. Now, at the intersection, we've got 0 degrees. At the end of the graph, we've got 360. And at the center, we've got 180. Now, we've got x equals to 60 degrees. So let's draw that onto our graph. So at x equals to 60 degrees, the y-axis will be equal to a half. And it is also equal to a half at x equals to 300, right? Remember, this graph is symmetrical, so we take 360 minus 60 and we get 300 degrees. Therefore, x is equal to 60 and 300 degrees. Now the question does not end here. We need to find the general solution, right? So x is equal to 60 plus 360 degrees k and 300 degrees plus 360 degrees k for k an element of integers, right? Now we may be tempted to stop there. However, we need to check whether the left side of the equation is equal to the right side of the equation. So let us do that now. So on the left side, let us substitute x equals to 60 degrees. We have root of 3 sine 60 plus cos 60. And we have, that should be 2. Now let us look at the left hand side for x equals to 300. So root 3 sine 300 plus cos 300. You put that into your calculator and you will get, let's see, -1. Therefore, the solution for x equals to 300 is invalid because the left hand side is not equal to 2. Now let us write the final answer. X is equal to 60 degrees plus 360 degrees k for k an element of integers, right? And this has no solution. Not no solution, sorry. This is an invalid solution. Right? And why is it the case? The left hand side does not equal to the right hand side. That's it. Please subscribe and let me know in the comments, what do you feel this question would be marked as? Maybe 6 marks, 8 marks? What do you think?